Hi everyone, today we're going to be talking about parabolas. Now you've probably seen parabolas before in a pre-calculus class or an intermediate algebra class, but when we're talking about conic sections, parabola looks slightly different in that we're talking about more characteristics of the parabola. So a parabola is the set of points in the plane equidistant from a fixed point F called the focus and a fixed line L called the directrix. Let's look at some characteristics of the parabola. So this vertical line here that goes through the vertex is called the axis of symmetry. Then we have the vertex, which we're probably used to. It's either the highest or the lowest point on the graph of the parabola. Then we have the directrix, which is perpendicular to the axis of symmetry. And then lastly, we have this point called the focus. Now, something that you'll come to find when you're working with these is that the distance between the focus and the vertex is the same distance between the vertex and the point where the directrix and the axis of symmetry intersect. So those distances are the same. The graph of the equation x squared equals 4py is a parabola with the following properties. The vertex is located at the origin. The focus is located at 0, p. The directrix is given by the equation y equals negative p. The parabola opens upward if p is greater than 0, or downwards if p is less than 0. The vertex of the parabola is halfway between the focus and the directrix, and the axis of symmetry is the line that runs through the focus perpendicular to the directrix. So here we have two graphs of two parabolas. One of them is facing upwards if the p-value is greater than 0, and then we have the parabola that's facing downwards when the p-value is less than 0. We can use the coordinates of the focus to estimate the width of a parabola when sketching the graph. The line segment that runs through the focus perpendicular to the axis with endpoints on the parabola is the focal diameter of the parabola, and the focal diameter is equal to the absolute value of 4p. So the focal diameter can be seen here, and it has a length of 4p. Here we have two examples of parabolas that are either opening to the right or opening to the left, and it is important to acknowledge here that neither of these are functions because they would not pass the vertical line test. Let's go ahead and move on to an example. Example 5 says, find the equation of the parabola with vertex at the origin and the focus located at 0, 2, and also sketch the graph. So I'm just going to go ahead and fill in the vertex on the plane that we have here, our xy plane. And then I also want to show that my focus here is at 0, 2. And remember, our focus is located at 0, p if it's facing upwards, which it is here. So that implies that our p-value is equal to 2. That also tells us that the equation of the directrix is going to be y equals negative 2. So that's going to be here. And we know that the equation of this looks like x squared equals 4py. And then we just found that the p-value is 2, so we can go ahead and plug that in. So we get x squared equals 4 times 2 times y. And if we go ahead and simplify that, we get x squared equals 8y. So we have found the equation, and we also want to sketch the graph. One other thing that I could point out is the focal diameter is equal to the absolute value of 4p, which in this case is the absolute value of 4 times 2, which equals 8. That tells me that the distance between the graph of the parabola here and here around the focus, we know that this distance is 8 units. So that's how I knew to place those ordered pairs there, and then I can go ahead and connect my graph through those. So my parabola is going to look something like that. And that concludes example 5. Let's go ahead and move on to example 6, which says, find the equation of the parabola with vertex at the origin and directrix x equals 4, and then we also want to sketch the graph. So I find that students will often get confused when you're given the equation of a line like this, so there's x equals 4, and there's y equals 4, and one of those is vertical and one of those is horizontal, and I find that students will often get confused by that. So my suggestion is I always tell students to make an XY table, and the first equation that they gave us, x equals 4, means that no matter what your y value is, your x value is always going to be 4. So it'd go through the point like 4, 0, 4, 1, 4, negative 1. And then I tell students to plot those points. So here's 4, 0, here's 4, 1, and here's 4, negative 1. And if we connected those points, it would form a vertical line. So that's how I tell the difference. And if you were graphing y equals 4, that would be a horizontal line. So that's just like a trick that I like to use. And then we know that the vertex of our parabola is at the origin. And since the directrix is on the right-hand side, that tells us that the focus is going to be here at negative 4, 0. And so our parabola is going to look something like that. Okay, so again, we know that our parabola is going to look something like that. And because it's opening to the left-hand side, that tells us that our p-value is negative because opens to the left. And remember that p is basically the distance between the vertex and the directrix, or the distance between the vertex and the focus, which both of those are 4. So we just need to make sure that we are indicating that p equals negative 4 since the parabola is opening to the left. So now we can do the focal diameter. We remember earlier that that was equal to the absolute value of 4 times p, which in this case is the absolute value of 4 times negative 4, which is the absolute value of negative 16, which equals 16. That means that if we start at the focus, we want to go both up 8 units and down 8 units. So 1, 2, 3, 4, 5, 6, 7. It goes off the graph. So I'm going to plot a point there and then down from the focus 8 units. 1, 2, 3, 4, 5, 6, 7, 8. So that's going to be like right there. And then I can go ahead and connect my points and make my parabola look something like that. Okay, so I went ahead and I sketched the graph. It also wants us to find the equation of the parabola. So let's go ahead and do that. And we know the equation is going to be y squared is equal to 4 times p times x. And we said earlier that p was equal to negative 4. So our equation is going to be y squared equals 4 times negative 4x. And that gives us y squared is equal to negative 16x. And that is our equation. So we went ahead and found both of the things that we wanted to, the graph and the equation, here in example 6.